In the next set of examples, we are writing the equation from a given parent function based on a series of transformations. So in number 10, I'm using the absolute value of x. So this is f of x equals, I have a vertical shift up 3, so I'm going to add 3 outside, and a horizontal shift right 2, so I'm going to subtract 2 inside. In number 11, a horizontal shift left 3, so I'm going to add 3 inside, and a vertical stretch of 4, so I multiply by 4 outside. In number 12, I'm going to reflect about the y-axis, so that means I have a negative inside. It's a vertical shift up 2 and a horizontal stretch of 5. So a horizontal stretch means I multiply inside. So f of x is equal to the absolute value of negative 1/5, because it's horizontal, so it's opposite, x plus 2. In number 13, we have a cubic function. So we're going to reflect about the x-axis, so that means I have a negative on the outside. I'm going to shift right 2 and a vertical shrink of 1/2. So I'm multiplying by negative 1/2 x minus 2 cubed. In number 14, I'm going to shift down 6 units. So I'm going to subtract 6 outside, and a horizontal shrink of 1/4. So I've got to multiply inside by the opposite. So this is going to be 4x cubed on the inside minus 6 on the outside. In number 15, I have a horizontal shift left 4, a vertical shift down 7, and a horizontal stretch of 8. So I have to multiply inside, a horizontal stretch of 8, and a horizontal shift left of 4. So I have x left 4 is going to be my plus 4, but I have to multiply that by 1/8 on the inside of my cube, and then I'm going to shift down 7. In number 16, I'm working with the reciprocal function. So a horizontal shift left 3 and a reflection about the x-axis. So f of x is equal to negative, for my reflection, 1 over x plus 3 for my horizontal shift left. In number 17, I have a vertical shift up 5 units. And in number 18, I have f of x is equal to a vertical stretch of 3, so 3 over, and a horizontal shift right 5, x minus 5. In number 19, I have an exponential function. So I'm going to reflect about the y-axis. So I have to multiply inside, and I'm going to shift right 8 units. So this would be x minus 8 but I have to multiply that by a negative because I'm going to reflect in the y. In number 20, this is f of x is equal to, I have a horizontal shrink of 1/2 and a reflection about the x-axis. So this is negative outside for my x-axis reflection, and a horizontal shrink means the opposite multiplier inside. Number 21, I have a vertical stretch of 6, a vertical shift down 3, a horizontal shift right 5, and a reflection about the x-axis. In number 22, we're using the logarithm. So f of x is equal to, they use a base of 2, so log base 2. I have a horizontal shift right 3, so x minus 3 inside the log, and down 5, so minus 5 outside the log. In number 23, I'm reflecting about the x-axis, so negative log base 2 of x plus 5 outside for my vertical shift up. In number 24, I have a vertical stretch by a factor of 5, a reflection about the y-axis, and a horizontal stretch of 3. So horizontal is opposite, so this is negative 1/3 x on the inside of my log. In the last 3 examples, you are writing the equation of the transformed function based on the parent function. So this parent function would be y equals x cubed. To identify what your transformed function is, you're going to find some of your critical points. So start with an x or y intercept. To get from this point to the transformed point, I had to move left 4 units and down 5 units. So this is f of x is equal to left 4 units inside my cube, down 5 units outside my cube. And then you check to make sure it hasn't been multiplied. The way you do that is you're going to move right 1, up 1 on the parent function. You should do the same thing on the transformed function. If they match, then you haven't multiplied by anything. Number 26, this is y equals the absolute value of x as my parent function in red. My transformed function, if I use my x or y intercept, I had to move right 2 units. So this is f of x equals the absolute value of x minus 2. And then my parent function, I'm right 1, up 1. But my transformed function, I'm right 1, up 3. That means I've been multiplied by a factor of 3 vertically. Number 27 is a little trickier because it's the reciprocal function. But if you use your origin as kind of your x or y intercept, with the reciprocal function, you don't really have one. In order to get to the center, this is your parent function, 1 over x. The center of your parent function is the origin. The center of my transformed function is here. So I had to move left 2 and up 1. So I have f of x is equal to 1 over x plus 2 plus 1. And then if you notice, this has been reflected. It's been reflected in the x-axis. So I have to multiply by a negative on the outside. Again, from your center point, we moved right 1, up 1 to get to our graph. If we hadn't been reflected, then we would go right 1, up 1. But in this case, we've been reflected, so we go right 1, down 1, and we get to our graph. So we have not been multiplied by anything.